to do, the three questions which I am going to do, they are very important. Okay. One is the stationary waves, the open pipe, closed pipe, and resonant Doppler effect. Okay. These are the last four topics of this lesson. Very, very important. So please be attentive, and if you have any doubts, please stop me and ask me there and there itself. These are all derivations. Okay. Now, standing wave. In standing wave, what will happen if suppose the wave goes forward like this? Okay, the wave goes forward like this. Then what will happen? It comes back, reflects back the other way. Okay. So moves forward, hits the wave, and it will reflect back. Forms a stationary wave or a standing wave. Forms a stationary wave or a standing wave. Okay. So these are said to be antinodes, and these are said to be nodes. Okay, antinodes, nodes. These are nodes. Okay. So a wave, a wave, uh, a reflected wave in the opposite end. Okay, or a reflected wave superimposed on the incident wave forms stationary wave forms stationary wave forms a stationary wave. Okay, so what is node? Node is denoted by n. So node means the the point where the displacement is zero. The point where the displacement is zero. Next is antinode. The point where the displacement is maximum. Where the displacement is maximum is antinode, and where the displacement is zero is node. Distance between two nodes. Okay, two nodes. Distance between two nodes or two antinodes. How much it is? Two nodes. Distance is how much? One wave is 2 pi, man. One wave is 2 pi, that is lambda. This will be equal to how much? From here to here it is lambda. Then half of that will be lambda by 2. Distance between node and next antinode, adjacent antinode, is how much? Lambda by 4. Is it clear? One wave, keep this in the mind. One wave is lambda. One wave distance of one length is lambda. Or length of one wave is lambda. Half of that, one loop is this much only. Half of that is lambda by 2. And again, half of that is lambda by 4. Is it clear? Is that clear? Yes or no? Give a thumbs up, man. Yeah, okay. Good. So, now we will go with the funda here, how it is formed. Suppose we are discussing about now nodes. What are the modes of oscillation? Now, fundamental frequency or first harmonic. First harmonic means if it is oscillating with only one loop like this. If it is only oscillating with one loop, what is the length? This length is L. Length is L. L is equal to what? Lambda by 2. So we know that V is equal to nu lambda. We know that V is equal to nu lambda. Okay. Now, if you take here lambda is equal to 2L. So V is equal to nu by 2L. Okay. V is equal to nu lambda. V is equal to nu by 2L. So this is the first one. Is it clear? So V is equal to 2L. V is equal to nu lambda and V is equal to nu by 2L. This is the first harmonic. First harmonic of is equal to mu lambda, or mu is equal to, yeah, first harmonic, yeah. Oh, sorry. V is equal to mu lambda. Nu is equal to V by lambda. So nu is equal to, I'll write here, nu is equal to V by 2L. Okay. Nu 1 we write, or nu 1. Okay. Or nu 0, fundamental harmonic. Nu is equal to V by 2L. This is for the first loop. When the when the loop, you just take the string, and if it is vibrating with only one loop, then that is fundamental frequency or first harmonic. Second one is second harmonic, or first overtone. Second harmonic or first overtone. Very, very important, this topic. Okay. Now, suppose what happens if it oscillates with one loop, like two loops. Again, length will not change. Length is same. But this is lambda by 2, lambda by 2. That will be equal to lambda. So, V is equal to nu lambda. Nu is equal to V by lambda. So, nu is equal to V by lambda, V by L. Multiply and divided by 2. 2 into V by 2L. So nu 2 or nu 1 is equal to what? 2 into nu 0. Can we write like this? V by 2L is 2 into nu 0. Third harmonic, third harmonic or third harmonic or second overtone. Third harmonic or second overtone. Suppose if it is given this way. So this is L. Length is equal to how much? 3 into lambda. So V is equal to nu lambda. Nu is equal to V by lambda. Nu is equal to V by, what is lambda here? Lambda is equal to 2L by 3. So it is 2L by 3. So 3 into V by 2L. So nu is equal to 3 into V by 2L is again V0. So this is nu 2. Is it clear? So this is first harmonic, second harmonic, third harmonic. Fundamental frequency, first overtone, second overtone. These are the names. Is this clear, all of you? Is this clear, all of you? Please give a
Yes,
thumbs
sir.
up, man. Okay. Okay. So we will discuss about this in one statement. Okay. The statement is, he says that the ratio of the ratio of frequencies the ratio of frequencies of the ratio of frequencies of frequencies of stationary wave stationary wave how it is written. It is nu 0 is to nu 1 is to nu 2 is to dash 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 1 is to 2 is to 3 is to dash dash dash. This goes, just remember this ratio. Okay. Now you will go with the open pipe. Okay. A pipe. What is a pipe? First of all, define. How can you define a pipe, man? Anyone? How do you define a pipe? Organ pipe. Okay. Organ pipe. Okay. Organ pipe, or wooden pipe. Wooden pipe for used for making musical notes. Okay. So that is a musical notes is said to be organ pipe or a pipe. Now we have two types of pipes. One is open pipe and the second one is closed pipe. Okay. Open pipe. It is open at both the ends. Open at both ends. Both ends is said to be open pipe. How it is? Open at both the ends. Now what happens? Here, if this is the pipe, it is open at both the ends. So first, what we are writing now here? Yeah, fundamental frequency again. fundamental frequency or first harmonic. Fundamental frequency or first harmonic. Okay, suppose if there is a pipe. Now suppose if it oscillates like this, the pipe oscillates like this. See, suppose you take a tuning fork, just keep it at the open end. So what will happen? The so there are compressions and rarefactions. Here, if you look here, there are rarefactions. If you see mechanical thing, there are rarefactions like this. But as it goes to the center, there are compressions scientifically. Again, what happens as they are going away, there are rarefactions. Rarefactions, compressions, rarefactions. So because of that, the compressions are nothing but a node and rarefactions are nothing but antinode. So a wave is formed like this. This is the tuning fork. Okay, the tuning fork we are taking and we are vibrating at the end of the wire. Okay, or a cylinder. Yeah, you can say. No problem. So this is a node and these two are the antinodes. Is that clear? So now what happens here? So L is the length of the thing. Here it is lambda by 4, lambda by 4. So L is equal to what? 2 lambda by 4, which is equal to lambda by 2. L is equal to 2 lambda by 4. Half of that is lambda by 4. So distance between antinode and anode is lambda by 4. 2 times of lambda by 4, that is equal to lambda by 2. Okay, so we can write lambda equal to 2L. So we have the formula V is equal to nu lambda. We have the formula V is equal to nu lambda. Okay, and nu is equal to V by lambda. V is equal to nu is equal to V by lambda. Now, if the pipe is oscillating with the first harmonic. So what are we going to do now? So implies nu is equal to V by 2L, or we write nu 0. Is this clear? If suppose you take a open pipe, keep a keep a I mean the tuning fork very close to it, then what will happen? It starts oscillating this way. N is the node, A is the antinode, L is the length of the pipe. So L is equal to 2 lambda by 4, lambda by 2, lambda is equal to 2L. V is equal to nu is equal to V by lambda. Just solve it, you get the answer. This is the first harmonic. Second one, that is second harmonic or first overtone. Second harmonic or first overtone. In this case, what is happening? See here, it goes like this. The loop is like this. See? So L is the length of the pipe. The total value will be how much? Lambda by 4, lambda by 4, lambda by 2. Lambda by 4 plus lambda by 4 plus lambda by 2. So that will be equal to 2 lambda by 4 plus lambda by 2. This will become 2. That is 2 lambda by 2 plus lambda by 2 is lambda. So here L is equal to lambda, V is equal to nu lambda, nu is equal to V by lambda. So nu is equal to V by L. Multiply and divide by L2. So V by 2L. So nu 1. So nu 1 is equal to 2 into nu 0. Okay. Is it clear? It should be 4, right? How come? 1 second. V by here 2 times lambda by 4. This is open pipe. The other one is closed pipe. Yeah. So this is second harmonic. Next is third harmonic or second overtone. Third harmonic or second overtone. See how it is. Pipe is same. Length of pipe is same. So that is L is the length. So this is lambda by 4, lambda by 2, lambda by 2, lambda by 4. So it is 3 lambda by 2. L is equal to 3 lambda by 2 implies lambda is equal to 2L by 3. V is equal to nu lambda. Nu is equal to V by lambda. Okay. Nu 2 is equal to V by 2L by 3. That is equal to 3 into V by 2L, that is equal to 3 into mu 0. 3 into mu 0. So,
Sir, I have a small doubt in second harmonic motion.
yes, sir, tell me.
Sir, how did you get pi by 4 plus pi by 4 plus pi by 2?
This is pi by 4. This is pi by 4. This thing is pi by 2.
Oh,
One
okay,
loop
that
is
okay.
one loop is pi by 2. Half of the loop is pi by sorry. One loop is lambda by 2. Half of the loop is lambda by 4. This is lambda by 4, lambda by 2, lambda by 4. Clear?
Okay.
Okay. Now next last one, the ratio of harmonics. Ratio of harmonics in open pipe is how much? Nu 0 is to nu 1 is to nu 2 is to dash 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 equal to 1 is to 2 is to 3 is to dash dash. Keep this now. So this is also one of the important. This can be asked in the blank for the closed and open pipe. This is for the open pipe. Any, is this clear all of you? Yes, sir. Is this clear all of you?
Yes,
Okay.
sir.
So we'll go with the next one. Next concept, that is closed pipe. Closed pipe. Pipe closed at both the ends. One end. Okay. Pipe closed at one end is said to be closed pipe. So first again we are going with a closed pipe here. We can go like this, a closed pipe only, or we can go this way also. It's up to you. So this is the way. Okay. So what exactly happens if you again see the physical scenario? So the waves will go. Okay, there are rare fractions. As they go there, there are reflecting back again from the base of the pipe. So there are compressions here and there are rare fractions. So compressions give rise to node and rare fractions give rise to antinode. So here again we are writing what is that? Fundamental frequency, fundamental frequency or first harmonic, fundamental frequency of first harmonic. Okay. So what happens here? This is, so this is L and this is lambda by 4. L and lambda by 4. Okay. So here what will happen now? V is equal to nu lambda, mu is equal to V by lambda. And we have L is equal to lambda by 4 and lambda is equal to 4L. So nu 0 is equal to V by 4L. This is the first one. The second one is second harmonic or first overtone. So what happens here? See here. So it goes like this. So L is the length of the tube. This is what? Lambda by 4 and lambda by 2. So we can write 3 lambda by 4. So L is equal to 3 lambda by 4. See, 2 times lambda by 4. So that is implies lambda is equal to 4L by 3. So V is equal to nu lambda implies mu is equal to V by lambda. So mu is equal to V by 4L by 3 equal to 3V by 3 into V by 4L. So this we can write as mu 1 is equal to 3 times of mu 0. Now, now here, third harmonic. Please ask me if you have it out. Third harmonic or second overtone. In this case, again, so it's like this. So here, this is L, L is the length, lambda by 4, lambda by 2, lambda by 2. So L is equal to what? 5 lambda by 4 implies lambda is equal to 4L by 5. V is equal to nu lambda implies mu is equal to V by lambda. Nu is equal to V by lambda is 4L by 5 implies nu is equal to 5 into V by 4L. So nu is equal to 5 into nu 0. That is nu 2. Nu 2 is 5 times of nu 0. So if you take the ratios, the ratio of frequencies in closed pipe, how it is? nu 0 is to nu 1 is to nu 2 is to dash 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 1 is to 3 is to 5. Odd numbers. In open pipe and in uh, stationary wave, it is 1 is to 2 is to 3. But whereas in this open pipe and closed pipe, it is odd numbers. Okay. Is this clear, all of you? Yes, sir. Is this clear? No one is saying anything. Yeah.
Yes.
Yes or no? Yeah, that's it. Last,
Yes,
almost
sir.
all we are coming to the end. Okay, don't worry. Next is the last one, that is beats phenomena. It is related to music. You might heard, you might be hearing the music every day. Okay, so beats phenomena. Okay, waxing and waning of sound. Okay, in simple words, waxing and waning of sound. That is said to be beats phenomena. What happens? Beats phenomena can only be observed. Suppose we have two frequencies, nu one and nu two. Okay, n is equal to nu two minus nu one. This is difference. Nu 2 minus nu 1. And it should be n should be less than or equal to 10. Then only we will be observing the beats phenomena. This is the condition. Then only we can observe beats phenomena. If it is less than or if the difference is less than equal to 10, then only we can hear the beats phenomena, because the perception of hearing is less than is 1 by 10. Is it not? What is the perception of vision? 1 by perception of hearing is 1 by 10, and perception of hearing vision is 1 by 16. Very good, very good, very good, Isan. So it's 1 by 16. 1 by 16 for eye and 1 by 10 for ear. So if it is more than 10, it appears, what happens if it is more than 10? It appears to be like a continuous sound. It appears like a continuous sound. So we won't be able to differentiate whether it is a vibration is happening or beats is happening or not. So that is why it should be less than 10. Now there are two cases which are definitely coming in examination. One situation is, suppose I have two tuning forks. I have tuning fork A and we have tuning fork B. Okay. Now I have waxed one tuning fork. Means I put some wax on one of the tuning fork. The tuning fork A is, let it be new A. If it is 256 hertz and this is around 300 hertz. Example. Not that much. It should not be that much. It should be 250 hertz. The difference should be very, very important, man. This is very, very important. This is only logical. There is no formula for this. Understanding and doing. There is no formula for this. One is 256, and so wax, before applying the wax, it is 256, and this was 250. After applying the difference is how much? N is equal to 256 minus, the difference is difference. 250 is 6 beats per second. But now what happened after applying wax? Then also it is 6 beats per second. After applying wax, okay, then also the value is again 200 to 6 bits per second. What is the meaning of this? Maybe we are writing n is equal to this. Whenever we put wax, the frequency reduces. The frequency reduces. What does it mean? 6, 6, 12. 12 means how much? How much we have? This will be 244. Maybe it might have become 244. 244 minus 256 equal to 6 beats per second. Understood now? There is no change in B, only change in A, because when you put wax on the tongue, it reduces the frequency of the tuning fork reduces. That is how much it reduces to 244. Is it clear? Is it clear, all of you? Yeah. Okay.
So,
Now, if you take one more situation, what happens now? Suppose there are two tuning forks, again A and B. Okay, we suppose when we file filing, filing of a tuning means take a sandpaper and rub it. Take a sandpaper and rub it. So what happens? The frequency increases. When you file, frequency increases. So what will happen here now? In this case, n is equal to nu a minus difference, nu a minus nu b. So n is equal to what we write now? Nu a minus nu b. So suppose example. Suppose the first one is again 256 hertz and this is 250 hertz. Now what I did, it is filing. Difference between both of them, n is equal to 256 minus 250 equal to 6 beats per second. After filing, what happens? It increases, right? He's saying that after filing also it is 6 beats per second. Means after filing, it might have become, oh, so sorry. I will take 260 better. Okay, this has 260. So it will become 4 beats per second. After filing also it is giving 4 beats per second. So what we are going to do now, increase this. Sorry, increase this. It becomes 264. 264 minus 260 is equal to again 4 beats per second. So when you put wax, the frequency will decrease. When you file it, frequency increases. Keep this in the mind. It's a simple thing. Okay. Now next one is last concept for today. That is Doppler's effect. Doppler's effect. Okay. Doppler's effect is what? Suppose an ambulance is approaching towards you. Suppose you are standing on the platform and a ambulance reaches is approaching. So you can see the sound zoom. What is that sound? Some sort of sound will be there, no? Ambulance sound. So it increases as it is approaching towards you. And as it is leaving you, the sound, the frequency of sound will reduce, decrease. So this, so that is what is it called? Apparent increase, apparent change in the frequency of sound, apparent change in the frequency of sound when there is a relative motion between when there is a relative motion between the source and observer. It can happen in light also. This Doppler effect is in light also. Okay, when the star is moving away, star is approaching towards Earth, all these things. Apparent change in the frequency of sound when there is a relative motion between the source and observer. Now, suppose there are total 8 cases, man, here. 8 cases. Source, observer, source, observer, 2, 3, 4, 5, 6, 7, 8. Source, observer. Source is observer is source is moving towards the stationary observer. Source is moving away from the stationary observer. Observer is moving towards the source. Observer is moving away. Both are moving towards. Both are moving away. Both are moving in the direction of observer. Both are moving in the direction of the source. Is it clear? Total 8 cases are there. But in your book, what they have done is they have given only one general formula. Only one general formula to explain this everything, explain this concept. Okay. Only one is enough to explain this concept. Okay. One formula.
Sir, first one, O is stationary, right?
O is stationary, S is source is moving towards the stationary observer, moving away, observer moving towards, observer moving away, source moving, both are moving away from each other, both are in the direction of observer, both are in the direction of source. Understood? Is it clear? So this is how 8 cases are drafted. Now, so there are formulas for this. Okay. So there are formulas for this. So what are the formulas now? He says that in the Doppler effect, nu is equal to uh, v by v minus a. Nu1. So I have taken like this v by v minus a. Suppose if it is source, it is a. If it is observer, for us observer, I write b. I'm using b instead of writing VA, VB. See, in some books they are taking VA for observer, VO for observer, S for source, and V is the speed of sound in air. All this confusion is there. So that's what I'm taking A and B. A for source and B for observer. That's enough. So the first one is is equal to first one. Is equal to uh, V by V minus A. Generally, the observer is coming in the denominator. Sorry, source is coming in the denominator. Observer is coming in the numerator. into nu. Nu is the speed of sound in the air. V by V minus A into V by V minus A into yeah. Nu is the frequency of sound in the air. So V is the velocity, A is the velocity of the observer. So what happens is when the source, suppose these are the waves. Now the source is coming very close to the observer. So what happens? Those waves get jumbled. They come closer. So what due to that the frequency increases. That's the reason why it increases. So here the length of the lambda, here the lambda is here the wavelength is lambda, here the wavelength is lambda dash. The wavelength reduces. Okay, because of that the frequency increases. That is the only reason. So nu1 is equal to the formula is V by V minus A into nu. Suppose if it is in the first, this is the first case. In the second case, nu2 equal to what we are writing? V by V plus A because it is moving away. See, uh, keep this in the mind. Okay, keep this in the mind. Suppose if the denominator is reducing, what is the meaning? The total value increases or decreases? See, it is new, same, V. But if it is 200 and this will become 195, the total value increases or decreases? Is beyond 1 or less than 1?
Yeah.
It is increases. Here it increases. Here, if it denominator is
So
bigger,
it decreases.
decreases. Yeah.
Increases.
So see when it is coming towards, increases. When it is moving away, decreases.
Decrease.
Third one, I'm coming to this one. Nu3. Nu3 is equal to what? This is coming towards V plus D by V into nu. Why? Because it is coming towards. Okay. So it increases. The total value increases. Fourth one. Nu4. Moving away, right? So V minus V by V into nu. The total value decreases. Observer is moving away from the source. Fifth one. In fifth one, nu5 is equal to give priority to source, man. Give priority to source. Is moving towards. Which one we have to take? If it is moving towards, take the first case. Okay. Take the first case V by V minus A. Stop there. After writing here, which one you will write now? Observer is moving towards. Which case is that? Observer is moving towards. Third case, nu3. So now it is nu3. So what is nu3? Nu5 is equal to V by V minus A into nu3. What is nu3 here? V minus B by V into nu. This and this will go away. Nu5 is equal to V minus B by V minus A into nu. This one. Is it clear? It's very simple. I'm not going to go in detail. Very simple way because this comes in the numerical. Sixth one. Again, give priority to source, not to the observer. Which case is this? Moving away, second case. Sixth one, this is second case. Okay, hold observer for some time. Second case, what is second case? Nu6 is equal to V by V plus A. Stop there. Nu, now when observer is moving away, which case is that? Fourth case. Fourth case, nu4. So V by V plus A, what is nu V4? V minus B by V into nu. This and this will go away. V minus B by V plus A into seventh one. What is the seventh one? View again priority to source. What is source? First one. So nu7 equal to first one you have to take V by V minus A. Again, observer is also moving away. Observer moving away means nu4. So which is equal to V by V minus A into nu4. What is 4? V minus B by V into nu. This and this will go away. V minus B by V minus A into eighth one. Nu8 is equal to what? Again, this is moving away. Hold observer for some time. Focus on observer, source. Second case. Second case is what? V by V plus A into nu. So V by V plus A. Which nu? Observer is moving towards third case. Third case. What is third case? V plus B by V into nu. This and this will go away. V plus B by V plus A into nu. But in textbook, what they have written? Apparent frequency nu dash is equal to V plus R minus B, V plus R minus A into E. But this is a general formula. But with this, we cannot define all the 8 cases. Is this clear, all of you?
Yes.
Yes.
Yeah? Yeah, yes, sir. Tell me.
In the fifth case,
Hmm.
should it be V plus B instead, not V minus B?
1 second. Fifth case, no, source is moving towards V
Yes,
by
sir,
V minus E.
Shouldn't it
Observer
be V
is,
plus B minus by V minus A?
one second. Nu 3, yeah, it should be plus. Yeah, V plus.
Okay.
Yeah, you tell me, you told me, you asked me something. Someone else. Yes, honey,
No, sir, I also had that doubt in the same.
same note. Is it clear now? Okay, we will have just 2 minutes. I'll just have a recap, then we can stop the class here. Okay. So we started with so we started with waves concept. One second. Yeah, we started with waves. Okay. Mechanical waves, progressive waves, then longitudinal waves and transverse waves. We discussed about that. Then we did the longitudinal waves first. Then we did transverse waves. Then we discussed about the equation of a wave. After discussing equation of a wave, we did after discussing the speed of a traveling wave. We did speed of a traveling wave, and then waves in a stress string. Then we did speed of a longitudinal wave. Okay, b is equal to, and we corrected that one. There is a Laplace correction. We did Laplace correction there. Okay, so this is Laplace correction. After Laplace correction, we went to the standing waves. Okay, reflection of a wave, that two waves interfering. Okay, so 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 then we did yeah, this is the superposition of two waves. This is the foreign formula, reflection thing. One is reflection and one is direct formula. Okay, no, this is the reflection, this is the direct one, adding both of them. Then this is the standing wave, first harmonic, second harmonic, third harmonic. Then this is the open pipe. Then this one is the closed pipe. Okay, and the last one we did is last one. What we did was uh, yes, last one was this no, Doppler separation. Okay, clear. So I will be sending this notes also, the videos also. You can watch once again. If you have any doubt, you are on Monday, tomorrow, and day after tomorrow, you can ask me any questions you have. Okay. So, anyways, the time is up. I will give the important questions. Okay. Don't worry. Okay. Is it clear?
Okay.
Thank you
Yes,
so
sir.
much.
Yes, sir.
Thank you so much for attending the class. Okay. All the best.
Thank you, sir.
Thank you,
Bye.
sir.
Thank you.
Okay. Okay. Bye.
Thank you, sir.
Take care.